StreetGamz, detection of feet movements on floor projections. StreetGamz is a moving projector platform which facilitates the gameplay through motion tracking and projection of playing area, with a distinct characteristic of being able to move and follow players in the game. The platform is mounted on a drone and consists of a projection device and a computational unit which is equipped with various sensors. This introduces novel abilities such as to move the gaming infrastructure before and during the gameplay and to free players from carrying the gaming equipment. This opens up new exergaming paradigms. In this presentation today, I will talk about system concept and prototype, where we'll focus on correcting projection distortions and the method we use for player detection. In other words, we will present how to perform feet tracking on floor projections. So let's look at our system. So the system concept envisions the usage of a small projector, such as Asus S1, and Google Tango smartphone device, mounted on a drone using a gimbal. We choose Tango smartphone as it is lightweight, compact computational device with a depth sensor. Depth camera is important for us because we plan to use it for player tracking. However, due to difficulty in obtaining Google Tango smartphone, we use Google Tango tablet in our prototype. We also didn't manage to mount our prototype to the drone yet. As we project an image to a non-perpendicular surface, we produce distortions in this projector. These distortions are known as Keystone distortions and can happen in horizontal and vertical direction, as is shown on these two images on the right. However, because our proposed system uses gimbal to stabilize in horizontal direction, we only need to correct for vertical distortions. So let's look at how we perform this correction. In order to perform vertical keystone distortion correction, we need to know the parameters of the projector's field of view and the angle of the projector in relation to the ground surface. Once this information is known, we can create a virtual scene, match field of view of the virtual camera with our projector, and rotate the game plane in the opposite direction to the detected tilt between the projector and the ground plane. We obtain this rotation using Google Tango tracking system. In this way, we can render graphics where perspective distortions from the tilt of the projector are removed as seen in this image. So, the second challenge of making projections interactive is to detect feet movement. In order to perform detection of feet movements, we need to initialize our floor plane and perform point cloud processing, in which we search for players' feet position using information from the depth camera. We also need to perform player identification, which we could do using RGB processing. However, in this prototype, we haven't managed to do that because it was not possible to capture information from the depth camera as well as RGB stream simultaneously. So let's look at our floor plane initialization strategy. We obtain 3D point cloud data from Tango tracking algorithm. We sort points into buckets based on distance in the direction of gravity, and we repeat these previous two steps for every new frame until the bucket threshold is reached. Once we have reached the threshold, we just use the buckets with highest number of points as our floor plane. After we have initialized our floor plane, we are ready to perform point cloud processing. So the goal of point cloud processing is to find feet of players. In the first step of this processing, we use min-max filter in order to isolate 3D points that are likely to represent feet of players. We use threshold of 20 centimeters. After we've done that, we move to the step where we try to group points into blobs. In this step, we actually simplify the problem by projecting these 3D points onto 2D image and search for spherical blobs within this 2D image, within the two-dimensional space. We use a threshold of 30 centimeters for the diameter of our blobs and follow the following blob detection algorithm. First, we randomly select one feedback point. Second, we check if there is any group defined within the threshold proximity to that point. If yes, we assign this point to this group or to the nearest group. If no, we create a new group. After we have assigned the point to a group, we update the position of that group by calculating a weighted average as shown in this formula below. So once we have blobs and we have their center point, we can find the intersection between the raycast through the center of this blob and our ground plane. And this is considered our final fit contact point. So the result of our prototype is shown on this figure. The green circles show contact points, whilst the green squares show activated grids. So currently the system runs at 10 to 15 frames per second, where the main limitation comes from the refresh rate of the depth camera of the Tango device. Another limitation of our system is that it currently does not distinguish between different players. This is all from me. Thank you very much for your attention. Software.